Hi everybody, and welcome to Lab 4 for SPSS. In this lab we're going to learn how to conduct an analysis of variance, or ANOVA. What I've got here on the screen is the data file. This is the complete data file with all of the variables that we've entered this semester. So here's our subject ID, age, gender, and so on. And over here on the right are the last two variables that you're going to be entering for this lab. Our treatment variable, TX, is medical treatment, medical shorthand for treatment or therapy. We've got our three groups entered, and then in the BDI category or variable, we have the Beck Depression Inventory score for each of our participants. And you may remember that to enter the data, you first have to define your variables over on the Variable View tab, and then you enter them on the Data View tab. But you've already learned all that in the previous tutorials and labs, so I'm not going to repeat how to do that. However, you notice that we, of course, correctly entered numbers for each of the three groups in our experiment, much like we did when we were entering gender and some of the other variables. But numbers are great for SPSS to do calculations with, but I want to see what those groups are. It's easier for me to keep track of things, and I'm just going to turn that on by turning on the labels feature of SPSS. And when I do, you see we've got all of our group labels showing up. You'll have to look back in previous labs if you don't remember how to set those labels. We went through it at least a couple of times in the past. Anyway, our data file is now ready for analysis. We entered new data. Fred's rule for data analysis is always what? Well, hopefully you said we need to visually inspect our data to create a histogram so we can see what the data look like, what its shape is, and more importantly, if there are any errors or outliers. So how do we create a histogram? Well, once again, hopefully you remember to do that. We go up to Analyze, and then Descriptive Statistics and Frequencies. When I click on that, I can move our BDI variable over, because that's the only thing that we want to look at. That's we don't look at a histogram for categorical or nominal data, for example. All right, we're going to be using the BDI variable and click Charts. We want a histogram, and I'm going to go ahead and have it show the normal curve. It'll smooth things out for me. Click Continue, click OK, and in just a couple heartbeats, we've got our table of frequencies and then the histogram. So looking at the histogram, the Beck Depression Inventory is a scale that runs from 0 up to the highest score that you can get is 63. And so as a result, nobody can get less than 0. And in this, it looks like we are slightly positively skewed because there were several people who scored in the 10 to 20 range, and then a few people that scored high. So it's not ideal. We want it to be normally distributed ideally, but in this case there's a slight positive skew. Okay, but nothing looks out of the ordinary. We don't have a Beck score of, say, 200 or -5, both of which is impossible on this scale. So we know that at least our data are valid from that standpoint. So now that we have visually inspected our data, we need to conduct the actual ANOVA. So I'm going to click on the star icon just to bring back our data file again. Now, analyzing three groups instead of two is done in a very similar way to when we did the t-test. We're going to go up to Analyze, and we still are just comparing means. And if you remember, here we have our one sample, our independent samples, our paired samples, t-tests, and a couple of other options. And at the bottom is one-way ANOVA. So that's what we're going to select, one-way ANOVA. Now the table here looks fairly similar to what we completed when we did the t-test. We've got our list of dependent variables, we've got our factor, which is another word for independent variable, and then of course different options and things we can do to tailor our analysis to what we're looking for. So in this case, if we scroll down to the bottom, what was our independent variable? Well, remember, we are comparing the three different types of therapies on their effect on depression. So the type of therapy is going to be our independent variable. That's how the groups are created. And then our dependent variable, there's only one of them. If we had more than one DV, we could move them all over here, and SPSS would calculate a separate ANOVA for each one. We only have the one Beck depression inventory, so I'm going to go ahead and just move that variable over to the dependent list. Now, contrasts, we're going to skip, not worry about it, but if you remember, with analysis of variance, even if it's significant, all we know is that the groups, however many there are, 3 or 4 or 5 or 10, all we know is that at least one of them came from a separate population or a different population than the others. Now, they might all have come from different populations, or just some of them, but more than one, and what have you. The problem is the F-test will only tell us that at least one of them is significantly different or comes from a different population. If we get a significant F-test, then we go ahead and do post hoc analyses. And post hoc, if you remember from our lecture, stands for after the fact. So let's click on the post hoc tests. And here you see all of the different post hoc analyses that SPSS will allow us to do. I won't go into all of the differences in them. The differences all tend to vary by how strict they are in correcting for type 1 errors or for how to deal with unequal ends and so on and so forth. Well, we're going to use the Tukey test. That's the one that I'm clicking there. Tukey is another name for the HSD test that was described in your text and during the week in our homework. So that's what we're going to do. Our significance level is 0.05. I can click continue. And now for options, there are some options that I tend to like to click. For example, I want it to give me a table of descriptive statistics for each of the groups, not just the whole experiment as a whole, but just each group separately. I also want to test for that homogeneity of variance. And if you remember in lecture, we discussed that the variance of the three groups should be fairly similar in order to calculate a valid ANOVA, and SPSS will run a test to see if we're meeting that assumption. And then lastly, I want it to give me a means plot, and that just means give me a graph of the means side by side so I can visually see what the data look like. So those are the options that I tend to routinely check when I'm conducting a one-way ANOVA. Go ahead and click continue there. And now our analysis of variance is all set up. We've set up the IV, we've set up the DV, we told it which post hoc tests to do, and we instructed it to give us any additional information that we might want to better understand our data. So once it's all ready, go ahead and click OK. And within a second, our analysis comes out. So you see in this first table of our one-way ANOVA, this is where it provides that table of descriptives that I asked for. So we have the medication group, we have the CBT, the cognitive behavioral therapy group. This is a talking therapy for depressed patients. And then we have the no treatment control group. We see that there were 10 subjects in each of the therapy groups and only 8 in the control group. While it's not ideal, we would like to have 10 participants in each, or at least an equal N in each group. It's, to be honest, not that common that you get exactly the same amount in each, just because sometimes people drop out or you have to eliminate data because it's been invalidated or something like that. So this isn't that unusual. And 8 versus 10, not a huge difference. If it was 5 versus 10 or 3 versus 10, I probably wouldn't want to do my analysis. I would run some more data and collect some more of my control group. Anyway, here we have the group means, the group standard deviations, the group standard errors of the mean, the confidence interval, minimum, and maximum. So those are all terms that you should be familiar with. If you're not familiar with them, You might want to refresh your memory on some of those concepts. Okay, we've been calculating standard deviations since about week 2 or 3, standard errors since week 5 or 6. So these are all terms that you should know. Next comes the homogeneity of variance table. This is a statistical test that compares the variance, which is the square of the standard deviation, which compares the variances of the 3 groups. And the bottom line is, if we look here at the significance, or the P column, if this was significant, then that means that the variances of the 3 groups are not equal. They are heterogeneous. Well, we've got a p-value of 0.157. Is that significant? I hope you said no, because it's not, right? We would see a p-value of 0.05 or something less than 0.05 if it was significant. So in other words, what this test is saying is that there's about a 15.7% chance of getting variances this far apart just through random variation. And that's certainly higher than 5% chance. So we're going to say that these variance scores do not differ significantly. Okay, so we're okay with that test of homogeneity of variance. Next table is the actual ANOVA, and this is the ANOVA summary table, much like what we saw or what you've been doing in your homework. Here we have the source of variability between groups, within groups, and total. Here are the sums of squares, which is the sum of the squared deviations of scores within each estimate of error. So we have the between group sum of squares and the within group sum of squares. Here are the degrees of freedom for those 2 sources of variance. Here's the mean square and a f. Remember, f is just mean square between divided by mean square within. So 1002.902 divided by 14.195 will give us 70.652. So that's our f value, the ratio of between groups variability to within groups variability. And here is our sig value, a sig of 0.000. Now this is something that actually came up when we addressed Lab 3 of why SPSS presents 0.000. This is also something that is described in the tutorial manual. So since I've described it in the past and it's in the manual, I'm not going to cover it here. I want you to review that information, seek it out, and try and figure out what this means. Does it mean that there is no chance at all of getting an f value this large just because of sampling error, or does it mean something else? Okay? And then if you determine that the ANOVA is significant, even though SPSS will calculate it no matter what, because we told it to, you would really only interpret it if it was significant. So here are those 3 comparisons for our study. So the way you read this table, the post hoc Tukey test, the Tukey HSD test, is you look at each row. So here, group 1 for this first comparison is the medication group versus the cognitive behavioral therapy group. The difference between those 2 means is 6 points. And if we look back up here, we see 13.5 and 7.5. That's a 6-point difference. That 6-point difference, if we conducted it by hand, comparing that 6 to our HSD, the honestly significant difference critical value, we see that difference would occur 0.004 or 4 times in 1,000 by chance alone. So is that significant or not? Well, you tell me. But here's a hint. The table already tells you if it's significant. So that's how you read that first comparison. The next comparison is once again medication group compared to, we'll just go down to the next row, to the no therapy group. So medication to no therapy, that difference is 14.875. And in the negative direction, if we look back up here, we see 13.5 minus 28.38 is going to give us that negative number. And that p-value the probability of getting that just by chance alone is, oops, there's another 0.000, similar to what we saw in the F table. Well, hopefully you resolved that issue and figured out if that means it's significant or not, and how to report that when you, are writing up your results for others. So we've now compared the medication group to the cognitive behavioral therapy group. We compared the medication group to the no therapy group. There's one comparison left. Can you think of what it is? Is it CBT to medication? No, we already did that up here. Comparing A to B is the same as comparing B to A, so that's not it. Is it comparing none to medication? No, same thing. None to meds is the same as meds to none. Now what we're missing is the CBT compared to the no group. The problem is SPSS does A to B and B to A for all possible comparisons, so it has a lot more information in here than you need. But we're just comparing cognitive behavioral therapy to no therapy. That's the one that's missing. Once again, 7.5 minus 28.38, that's going to give us a pretty large difference of negative 20.875. And here's that p-value. It says 0.000. Once again, you tell us what that means. And so you now have all of the information you need to write up the ANOVA. We've got all of the group means and standard deviations and whatnot. We have the ANOVA summary table with the p-value telling us if that effect is significant or not. And then we have the post hoc Tukey test or HSD test that compares each of the groups, meds to CBT, meds to none, and CBT to none. So that's an analysis of variance in a very quick nutshell. And if we scroll down further, we see, we're not going to worry about that table there, but we see the table of means. This would be the mean depression level of patients at the end of 4 months of medications. This would be the mean depression level for our CBT group after 4 months of cognitive behavioral therapy. And then this would be the mean depression level of the no treatment control group after the same 4 months. Now let me show you a little trick on these tables here, these charts here. If I double click the chart, that's going to activate it. And I want you to go ahead and do this in your own analyses. We can now start editing all kinds of things. We can change the words by just double clicking things. And windows will pop up and we can change the font and scale and labels and all sorts of things. What I'm going to change here is I don't like line graphs to display categorical independent variables. So if I click once and then double click on that line, I have to scoot all the way over here to where it says variables. I just kept clicking until I got to variables. And see where it says element type? If I click on that and scroll up, I can select bar graph. And then if I click apply, notice what happens is we get these 3 bars showing up. So from there I can then start messing with things like I can add error bars and whatnot. I'm just going to, here, I will change the fill just to make it black, because I like nice black and white graphs. When I click apply, it shows up on the graph. I can start closing windows. I'm going to close this active editing window. And you see there's our new graph, and we can see, relatively speaking, how high this group performed, how high the CBT group performed, how high the no group performed. And that is the entire ANOVA, right? Start to finish. We visually inspected our data. We ran the ANOVA, we got our descriptive statistics, we tested for homogeneity of variance, and then we have the ANOVA summary table. Afterwards, SPSS, we told it to conduct that Tukey HSD test. I hate that little pop-up window. The Tukey HSD test. Remember, you only will interpret it if your ANOVA is significant. But when you do interpret it, you have to walk the reader through, or walk your professor through, all possible comparisons of the groups and tell whether they are significant or not and in which direction. And then lastly, we have a graph of the means. So I'm going to, well, I should save that file, and I tell you how to save it in your instructions for the tutorial. So that's it. You will then have a completed analysis of variance using SPSS. So that'll do it. Thanks for watching.